Hey guys, this is 4.1, Solving by Factoring. This entire unit is about solving. There's different ways to solve. We'll have 4 different ways that we'll do that. The first is to solve by factoring. So our last unit was factoring. So all of these problems that we're going to run into is we are going to factor. Find the two things that multiply and add. We'll see if we'll need to use the shortcut or if we can use if we have to use a box. Okay, so you're going to be doing that again, but with one extra thing is we're going to solve. Okay, we're going to solve for x. Alright, so let's look at this first equation. It says a times b equals 0. What do you know about a or b? Hopefully you realize that either a or b, one of them at least, or both, have to be 0. If a was 0, then it doesn't matter what b is, the whole equation would be 0. Or if b was 0, it doesn't matter what a is, 0 times a would give us 0. So either one of those or both have to be 0, and that is what the zero product property is. So if a times b equals 0, if we're multiplying two things and it's equal to 0, then a or b or both must be 0. So we will use that to solve. So I will start by having our problems already factored. So you see these binomials that are being multiplied by each other. You're going to start with that just so we can get a handle on the zero product property. And then from there you're going to actually have problems in standard form and you're going to factor. So these are called factored form. So you've already factored them. And we need to know what are the solutions. So just like we talked about a times b equals 0, we're multiplying two things. Here we are multiplying these two binomials. This could be a, and this could be b, and we're multiplying them, okay? So, sorry about that. So basically we want to know, what does x need to be to make that be 0? So we know that either x minus 5 is equal to 0 or x plus 1 equals 0. If one of those is equal to 0, then the whole thing is equal to 0. So we could just add 5 to both sides and we'd get x equals 5, or we could subtract 1 from both sides and we'd get x equals negative 1. Okay, so this isn't too bad by just looking at the equations. You could probably look at that binomial and say, well, what does x need to be to make it be 0? Well, obviously 5 would work because 5 minus 5 is 0. And same thing here, if x is negative 1, then negative 1 plus 1 is 0. Okay, but if you're ever stuck, please just set them equal to 0. That's what we're saying, is that either a equals 0 or b equals 0. So that's what we're doing here, is we're saying a equals b, or 0, and this would be b equals 0. Okay, and we set those up and solve. So here we could probably do it a little quicker. Again, what does x need to make this be 0 would be negative 2, and here x would have to be negative 8. So those would be our solutions. And this is a list of solutions. It's not an ordered pair, so don't try and write it as an ordered pair. No parentheses. Okay? Alright, C. This is one that a lot of people forget or struggle with. But again, this is like our A, and this is like our B. So either x has got to be equal to 0, or x minus 4 has got to be equal to 0. So this one's already solved. That's one of our solutions, would be 0. And then here we just need to add both sides by 4, and our other solution would be x equals 4. Okay? These are the types of problems when all you can take out is the greatest common factor, and we'll have an example of that in a little bit. Alright, here what we're talking about is this is A, this is B. The greatest common factor doesn't affect your solution. We'll use that for later in our next unit. It will do something when we are trying to graph quadratics, but for solving, the greatest common factor won't affect your solutions. So we have What will make this be 0 is if x equals 3, or for here, x would have to be negative 11. Okay, so this is why I really like it if you would maybe do what we did at the very beginning, like set them equal to 0, because this is where people get stuck. They're like, what? Now we have 2x plus 1. Okay, but still, this is A, this is B. Either A's got to be equal to 0 or B's got to be equal to 0. So 2x plus 1 has got to be equal to 0, or x minus 5 equals 0. Okay, so we would solve, subtract 1, and then we would divide. So x equals negative 1/2, or we could add 5, and we just get x equals 5. So our other solution would be 5. Okay? So please, if you're ever stuck, just set it equal to 0 and solve. This would be a good time to just like plug these in and show how this works. So if we plug negative 1/2 into this equation, we'll just make sure that it actually works. So if we multiply that by a negative 1/2 plus 1, and we multiply that by negative 1/2 minus 5 equals 0. So we want to check and make sure that works. Well, when we multiply this, the 2 on top and 2 on bottom would cancel, so we'd just get negative 1 plus 1, which is 0. Okay, and then it doesn't matter what this is. This would give us, I don't know, negative 5.5. Probably don't want to have it as a mixed fraction, but it doesn't really matter because when we multiply something by 0, the whole thing becomes 0. Okay, and then we could also try it with 5. If we plug 5, oops, it's 2 times 5, we plug 5 in for x. Well, here we'd get 4. This would be what? 10 plus 1 is 11, and then 5 minus 5 is 0. And again, 0 times anything makes it be 0. So it works, okay? So those are the only two things that could plug in, that would make the equation be true. Okay, and again, those are called your solutions. Sometimes they're called the zeros. Okay. All right. So then last example, if you want to give that a try, it's about the same, but we should have 2/3 and positive 2. Those would be our solutions if you want to give that a try. All right, so all of the problems that we're going to have from now on will be in, at least for today, is in this form, standard form. It's very important that you make sure that the one side is equal to 0. You can't try and do factoring until everything is on one side. And that's pretty much the same case for all the ways that we'll solve. Okay, everything needs to be on one side. All right, so make sure it's in standard form and is set equal to 0. And then we can take something that looks like this to look like something like that by factoring. Okay, so how do we do that? We factor. So we'll do a few of those. We're not going to do all of them. I'll have filled in notes, so if you want to do all of the problems in the review, or the notes, then you can, and you can find how that works and check the answers and all that if you'd like. But again, always we need to make sure that it is in standard, all on one side. So that's number 1. Number 2 is we'd want to check for greatest common factor. And then next would be factoring, so like glasses. Okay, so here this is already in standard form. There's no greatest common factor, so we'd go into glasses. We need to find the two things that multiply to 8 and adds to negative 6. So this shouldn't be new. We've done this so many times. So this would be something like negative 2 and negative 4. And if we multiplied, that still works. And that gives us 8p squared. And then from here, since a is 1, we could use a shortcut. I'll do an example where you can't use the shortcut in case you've forgotten that as well. So we have p minus 2 and p minus 4 is equal to 0. So that's still an equation. And then we'll find our solutions. So again, if you want, you could set them equal. This is like A, this is like B. We set them equal to 0, so p minus 2 can be equal to 0, or p minus 4 has got to be equal to 0. Okay, because if one of those if either of those work, then the whole equation is 0. So we would add 2, so we get p equals 2, and we could add 4, and we'd get p equals 4. So that's like the whole thing. Okay, we start from standard form, we factor, and then we use the zero product property. Okay, so that's what we hear. Alright, so let's just do a few on this other page. Looks like we'll maybe do 4 of them. Again, there's like steps, if that's helpful. And we'll try and fill in these other things. We already talked about the greatest common factor doesn't affect the solutions. Okay, and then a variable by itself. We already had one kind of like that. Here we have a variable by itself. We always just end up getting a 0 solution. So if you want to put that in there, that's great. Okay, so let's do these together. A we've already done just like that first page. A's 1, we can use the shortcut. B, what do we do first? Again, we always check for the greatest common factor. Here it's -1. So we take out that -1. We divide everything by that -1. And then we could do glasses. So we'd figure out what multiplies to 4 and adds to 4. Okay. So that would have to be what? 2x and 2x. And then we could use the shortcut. So we got -1, x plus 2, and x plus 2. And then we could use the zero product property. So again, either x plus 2's got to be equal to 0, or x plus 2's got to be equal to 0. So I did this one on purpose because this is a situation where we would end up getting 2 solutions that are the same. And I would like you to write both. Even though they're the same, it will help you to realize that there's always 2 solutions, okay? Always, oops, spelled that wrong. They can be identical solutions, but there's always 2 solutions, okay? So let's give D a try. Again, everything needs to be on one side. So we would need to subtract 3 from both sides. Okay, and then we could either use the difference of squares, or you could still do glasses. You just need to realize that it's x squared plus 0x minus 25. And you could do glasses. But since we learned about the difference of squares, here we're just going to write down our answers using the difference of squares. So square root gives us x plus 5 and x minus 5. Okay. Again, we could do glasses. 2 things that multiply and add would have to be 5 and -5. That would multiply to -25 and add to 0. Okay, and you'd end up getting the same thing. So our solutions here would be x equals, again, we could set them up as equal equations. Maybe we should do that. So we'd subtract 5, so we'd get -5, and then the other one we would need to add 5. So add 5, and we would end up getting positive 5. Okay? Alright, next, this one, let's talk about that. Again, first off, needs to be standard form all on one side. So we need to get rid of that 5, or -5. And then A's not 1. We can't factor out an 8, so we're going to need to use the box. So it needs to multiply to negative 8x squared and adds to 2x. So think about that for a sec. Hopefully you got like negative 2 plus 4. That gives us what we need, and then we'll probably need to have those x's here. Okay. All right, and then just a reminder, we are doing substitution. We get 8x squared minus 2x plus 4x minus 1, and then we could use the box. So we've got, and again, a lot of you will just go straight from here to the box, which is just great. Greatest common factor would be 2x, and then 1, 4x, and negative 1. So we've got, 4x minus 1 and 2x plus 1 equals 0, and then we'll use the zero product property. So either 4x minus 1 has got to be equal to 0, or 2x plus 1 has got to be equal to 0, and we'll solve. So we add 1, and then divide by 4. So one of our solutions would be 1/4, and then we'll subtract 1, divide by 2, and the other solution is negative 1/2. Okay, so that is an example of when we can't use the shortcut. Alright, last one, actually we'll probably do h as well, just so we have a good example of that. Okay, this is in standard form, everything's on one side. We need to check for the greatest common factor, so that here would be n. We need to factor out an n. Okay, and then we'll use the zero product property, so either this has got to be equal to 0, or this has got to be equal to 0, and we'll solve. So we'd add 7, so we've got n equals 0, 7. Those were our two solutions. And again, you can always plug those in, and you can verify that it makes it work. If you plug 0 in for both, obviously 0 squared 0, minus 7 times 0 is 0, gives you 0. If you plugged 7 in, we'd get 7 squared, which is 49, and then we'd do minus 7 times 7 gives you negative 49, which gives you 0. So you can always check if you wanted to. Alright, and then last one, everything's on the one side, okay, and this is a difference of squares. So we could do square root gives us 2a plus 3 and 2a minus 3 equals 0. Okay, so this is really a lot like D. Okay, but here we definitely need to use like set it equal to 0. So either 2a plus 3 equals 0, or 2a minus 3 has got to be equal to 0. And you just solve. So subtract 3, divide by 2, and we do the same for the other. Divide by 2, and we'd get 3/2. Okay, so that's it. So we're just factoring, doing the same types of problems we did for our last unit. And it's just that when you get your answer, we do the zero product property. We set the binomials equal to 0, and we solve. Those give you the solutions of the equation. Okay? All right, let me know if you have any questions. We'll see you later.